This question is about objects within non-uniform fields, and specifically a charge within an electric field. So we're told that the diagram shows a small negative charge at a point in an electric field, which is represented by the arrowed field lines. So what's important, a few factors within the diagram that are important. You've got the fact that these lines are converging. So as we go from right to left, they're converging, and we've got arrows giving us the direction. We have a dotted line that is, we are told, intersects the field lines at 90 degrees. And that's relevant because if they intersect at 90 degrees, then they're perpendicular, and that would be an equipotential line. So any line which cuts through the field lines at 90 degrees gives us an equipotential. So moving across these has no change in potential energy. We're also told that on this equipotential line, we've got a negative ion. Now, the fact that it's negative is important. It's not just an ion, it's a negative ion. So we've got the direction of the electric force, but remember that's the direction of force on a positive charge. So the convention is that the arrows tell you the direction of force on a positive charge. So then we're given this statement. One of these statements is correct, and we probably need to go through all of them and rule them out, and hopefully we'll be left with one that makes sense. So when a negative charge is displaced to the left, so it moves to the left, magnitude of electric force on it decreases. Now, magnitude of the field strength is to do with the spacing of the lines. And if you go to the left, regardless of the charge, the field lines are closer together. So the magnitude of the field is stronger because the lines are closer together. So this is moving into a stronger field. So the electric force will be greater. The force will be greater in this direction because it's a negative ion. So the force is in the opposite direction to the field lines, but it will still be greater because these lines are closer together. The spacing has decreased. So that one's not true. To the right, its potential energy increases. Now, if it was a positive charge and you move it to the right, you are doing work against the field. So yes, its potential energy would increase, but it's not. It's a negative ion. So the direction of the force on this is this way anyway. So we're allowing the field to do work on it. So its potential energy decreases, and that would result in it getting faster. So actually, that's not correct either. Along the line PQ, and I haven't put the Q on, along the line PQ, it's an equipotential. So potential energy decreases. No, its potential energy will stay the same. And then the final one, which hopefully is correct, along the line PQ, the magnitude of the electric force is unchanged. Well, along this line, the spacing, if it's drawn carefully and you can have a look, the spacing of the field lines does not change. Might do my sketch of it, but on the actual diagram, that spacing, you could measure it, that spacing does not change. So D is the best correct answer.